Alright, in this video we're going to talk about multiplying polynomials. Alright, so to multiply polynomials, basically what we do is we use the distributive property, and then we also use the laws of exponents when we are multiplying variables raised to powers multiplied by other variables raised to powers. Alright, so the first example here we have 2x plus 1 times 3x minus 5. Right, so one polynomial here, 2x plus 1, the other one is 3x minus 5. They're in two parentheses right next to each other, which means we have to multiply those two together. Right, so we're going to use the distributive property and the laws of exponents to do this. So the basic thing when you're multiplying two polynomials is, the way to approach it is start with your first parentheses, your first polynomial. Every term in that polynomial has to get distributed to the second polynomial, or that second set of parentheses. Right, so I take my first term in that first polynomial, the 2x, and I distribute that 2x to both of the terms in that second parentheses. Right, so I'm going to multiply the 2x times 3x, and I'm going to multiply the 2x times the negative 5. Right, so that's what we mean by using the distributive property. Right, and then I'm also going to take the second term in the first parentheses and distribute that to both of the terms in the second parentheses. Right, so I distribute the 2x to everything, and then I distribute the 1 to everything, and that's how I multiply two polynomials. Or really, not even only polynomials, but anytime you have two expressions in parentheses that are being multiplied together that are separated by addition and subtraction, they don't have to be polynomials. You still use the distributive property to multiply that out. All right, so 2x gets distributed to everything, the 1 gets distributed to everything. All right, so when I multiply the 2x times the 3x, well, 2 times 3 is 6. X times x is going to be x squared. Right, and this is where it says up here to use the laws of exponents. When I multiply an x to the first power times an x to the first power, right, when I have that same base raised to a power, I add the two exponents together. Right, so x to the first times x to the first, I add 1 plus 1, and I get x squared. Right, remember, when you're adding or subtracting polynomials, which if you didn't see the last video I did about adding and subtracting, we talked about it there. But when you add and subtract polynomials, you don't change the exponents at all. When you multiply polynomials, you do change the exponents, right? Because there you have to use the laws of exponents, because when you multiply an x times an x, it gives you an x squared. All right, so make sure you're aware of that when you're doing this. So 2x times 3x is 6x squared. 2x times minus 5, when I distribute the 2x to the negative 5, that's going to give me a negative 10x. Right? That's still an x to the first power, because this x here and that minus 5 doesn't have an x attached to it. So I just multiply the 2 times the negative 5 to get negative 10, and that x to the first power stays to the first power. All right, so that's distributing the 2x to that second parentheses. Now I distribute my next term, which is this plus 1, to that second parentheses. Right, so 1 times 3x is going to be plus 3x. 1 times negative 5 is going to be minus 5. All right, so I've distributed everything from the first parentheses into the second parentheses, and now the only thing I have left to do is to clean it up, right? Combine any like terms and simplify things as much as I can. All right, so I've got a 6x squared here, which I don't have any other x squared terms, so that's just 6x squared. I have a minus 10x and a plus 3x, right? So the minus 10 plus 3, that's going to be a minus 7x, right? And again, remember, when we're adding or subtracting those terms or combining those like terms, we don't change the exponent. And then we have that minus 5, that constant at the end, and there's no other constant, so that just stays minus 5. All right, so when I multiply 2x plus 1 times 3x minus 5, I get 6x squared minus 7x minus 5. Right, that's my product of that multiplication. All right, now, what we just did here, when you're multiplying two binomials together, remember, a binomial is a polynomial that has two terms. So when I'm multiplying two binomials, the little way to remember what to do there is what they call the FOIL method. Right, F-O-I-L, right? F stands for first, right? So multiplying the first terms, the 2x times the 3x, right? That was the first thing we did when we distributed that 2x. I multiplied those first terms together, right? So that F, that first, gives me the 6x squared. The O is for the outer terms, right? That's when I multiply the 2x times the 5x. Those are the outer terms, right? The ones on the outsides of our parentheses, or the furthest ones out in our parentheses. So the 2x times the minus 5, that gave me that minus 10x there for that O. I is for the inner terms, right? The ones that are towards the middle. When I multiplied the 1 by the 3x, that was the inner terms, right? So that was that plus 3x that I got there. And then the L is for last, right? Multiplying the last term of each polynomial. So 1 times negative 5, that gave us the negative 5 there. That was the L of our FOIL method. All right, so a lot of people learn that as, oh, when I have these two things multiplied together, I have to FOIL that. So if you never heard that before, but you hear somebody say FOIL, that's what they're talking about. But really what you're doing is you're taking the 2x and you're distributing it to both of these things, right? The first and then the outer, and then you're taking the 1 and distributing it to these two things. It's the inner and the last. All right, so that's what we call the FOIL method. Now the FOIL method though only works if you're multiplying two binomials together, right? This one has to have two terms, this one has to have two terms, then the FOIL method works, right? But what if you have something like example B, right, where we have a binomial 2x plus 3, but then we have a trinomial, right? We have three terms here, x squared minus 5x plus 4. Well, when you have something like that, the FOIL method doesn't apply because we have more than just the inner and outer terms here. We have this extra one in the middle. So FOIL doesn't actually work here, right? So which is why I prefer to teach this and to show you how to do it by using the distributive property. If you remember that you have to distribute everything from this first parentheses into the second parentheses, then it doesn't matter how many terms you have, right? So I'm going to do the same thing as I did up above. It's just since I have three terms here, there's going to be some extra stuff to do, or some extra steps in the problem, right? So if I'm multiplying the binomial times the trinomial, I start with my first parentheses, whatever that first term is, I distributed it to everything that's in the second parentheses. So I'm going to do 2x times x squared, which is going to be 2x to the third power. Remember, an x to the first times an x squared, we add the exponents 1 plus 2, and I get an x to the third. Right? I distribute the 2x to the minus 5x. That's going to be a negative 10 x squared. Right? Again, x to the first times x to the first. Add the 1s, and I get x to the second. And then I distribute the 2x times the plus 4, and that's going to be plus 8x. Right, so again, it doesn't matter how many terms I have in either one of those parentheses. I start with the first term in the first parentheses. I distribute that to everything in the second parentheses. Then I move to the next term in the first parentheses, and I distribute that to everything that's in the second parentheses. All right, so I'm going to do 3 times x squared, so that's going to be plus 3x squared. I'm going to do 3 times minus 5x, so that's going to be minus 15x. And I'm going to do 3 times 4, which is going to be plus 12. Right, and when you're doing this where you're actually like multiplying and doing that work to figure out what things you get down here, just be careful with the basic rules that you've learned before. Like when you multiply a positive times a negative, like positive 3 times negative 5, the answer is a negative 15. If you multiply two negatives together, it gives you a positive. Right? Remember the rules of exponents. An x times an x squared is an x to the third. An x times an x is an x squared. Right? It's those little things. Like once you understand the process of how to do a problem like this, that you're distributing everything to the second parentheses, then it's just a matter of not making those little mistakes with the positive and negative signs or messing up with the exponents or things like that. All right? So it's a couple things to get a problem like this right. It's understanding what you have to do as far as distributing and multiplying everything to get the answer. And then it's being real careful and paying attention to the details and not making little mistakes, right? Now, once we do this, it's just like what we did up here, except when I distributed each of these things, I had an extra term here to multiply it by, which means my next step now has extra terms, right? But it doesn't change what I do. I still now, once I multiply everything out and I distribute everything from the first parentheses to the second parentheses, now I combine like terms. All right, so let's see what we got. I have a 2x to the third, and I don't have any other x to the third power, so that's just a 2x to the third. I have a minus 10x squared, and I have a plus 3x squared a little further along. So negative 10 plus 3 is going to be negative 7x squared, right? Again, being careful with a negative plus a positive. How do you combine those together, right? Remember all those pre-algebra things that you learned, adding integers and subtracting and all that stuff, right? So negative 10 plus 3 is negative 7. Remember, when you're adding and combining like terms, the x squared doesn't change, right? Just the coefficients in front. All right, I have a plus 8x, and I have a minus 15x, all right? So those are like terms. They both have an x to the first power. Positive 8 minus 15 is going to be minus 7x. And then I have that plus 12 at the end, and that's the only constant I have. And so here's my result of this multiplication, 2x to the third minus 7x squared minus 7x plus 12. All right, so that is multiplying polynomials, right? If you only have two terms in each polynomial, if both of them are binomials, you can use what we call the FOIL method to do that. But as soon as one of those polynomials gets more terms than just two, the the FOIL method kind of breaks down, but you still use the same principle. You just take the first thing here, the 2x, multiply it by everything, take the 3 here, multiply that by everything. If there was a third term in the first parentheses, you would then multiply that term times everything in the second parentheses, and then once you get all that at the end, you just clean it up by combining the like terms together. All right, so that is multiplying polynomials.